That's pretty spicy. Check.
All right, welcome everybody to this live stream today on an introduction to Simulink. So we'll get into what Simulink is, how to use it, and getting started with it. But I thought we'd start with just some quick introductions.
Yep.
So my name's Sam Reinsel. I am a student competition technical evangelist here at the MathWorks. So really what I do is I work with different student competitions that we're involved with, mostly automotive competitions, but a lot of stuff here and there.
Yep, and my name's Nishan Nekoo. I'm an application support engineer at the MathWorks. I'm in the engineering development group. And yeah, I participated in an automotive student competition, one of the ones that Sam organizes back in the day, but now I'm working here at the MathWorks, so yeah. Happy to be here today.
Yeah, and you know, we're here to talk about Simulink because it's a big part of not just the academia, but also in industry. It's really heavily used in automotive and aerospace applications. We're not going to get too in-depth into modeling like cars or airplanes today, but hopefully what you'll have by the end of this is a really good starting point of what the software is, how to get started with it, and how to use it in your applications for modeling things that you might be working on control systems for, or just other components that you're trying to understand the behavior of.
Yep.
So yeah, so I think you've got the Simulink start page up here, right,
Yes,
Nishan?
I do.
Yeah, so if you go to the MathWorks website and you pull up the product page for Simulink, what you're going to see is this page. And what I wanted to call attention to here is Simulink is for model-based design.
What does that mean, Sam?
What does model-based design mean? So model-based design is the idea that, you know, in the automotive industry, the aerospace industry, really across all engineering disciplines now, building physical prototypes is expensive.
Yep.
And you really can't wait until you have a prototype of, you know, an engine or a transmission or something that it's not even actually ready to go into production, but you need to start working on your control systems there before you get to that physical prototype.
Yep.
And the way that we do this is through models. And so model-based design is trying to work out design problems with our system, try to understand how different components are going to interact, and how to write controls for those systems before we get there. So we do all of that using a model.
Yeah, so I mean, there's two parts to this, right? There's modeling, which is the simulation part, where
Yep.
you create these models, you run simulations, you can perform analysis. What's the fuel economy of this car going to look like once it gets into production one day, you know? And then there's the second part, which is automation. So in that part, you get coding and verification. So instead of writing code manually, you remove errors from the process by automatically generating code using MathWorks products. And then you can verify and validate all this code before going into production with your thing that you're manufacturing.
Yeah. So not to plug another live stream as soon as we get started, but I'll actually be back next week on our YouTube channel to do another live stream about code generation. So if you're interested, be sure to get subscribed. You'll get a notification about that live stream. But today we're really talking about introduction to Simulink, getting started with the software, the code gen side of it, both in MATLAB and Simulink, we'll talk about next week.
Yeah, so enough talking. Let's do a little bit of showing here.
Yeah.
So I have MATLAB pulled up, and something that we always talk about is what is Simulink? And Simulink is really built on top of MATLAB. So Simulink doesn't exist on its own in its own world. Simulink is based off of MATLAB, and so everything that you can do in Simulink, you can pretty much do it from MATLAB itself. So how do we launch Simulink? There's this beautiful icon right in the middle here that you can use, but I love MATLAB, I love programming, so I'm going to use the MATLAB command window to launch Simulink instead. So you can just type Simulink, hit enter, and it's going to launch this Simulink start page. There's a lot going on here, but the thing that you need to pay attention to is all these models here that you can use as starting points. So you can start with a simple blank model here, but if you're trying to do a more creative or a more in-depth kind of project, you can always start with things like aerospace block set for an aerospace application, communications, powertrain block set for vehicle-related projects. So there's a lot of templates here that you can use as a starting point. In addition, there's also examples, and these are also like really great starting points. If you ask me to build a mass spring damper project, I'm not going to be like, I'm not going to build this from scratch. Let me go check out the examples, see what's out there, and I'm just going to play with these examples, try to break them, and just have fun with it. So the examples are another great resource that you have. And one thing I did want to talk about is this Learn tab over here. If you're using Simulink for the first time, like many of you might be, there's some great resources that the MathWorks offers to learn these products from scratch. One of them is the Simulink on-ramp over here. You can launch that, and it's a 2-hour module. It kind of walks you through all the basics of Simulink, some of which we'll be covering today. So can be like a fast-track process here, but really in-depth and good coverage of what the basics of Simulink are. Then there's also other products like Stateflow, Simscape, circuit simulation, etc. So a lot of things that you want to learn, you can learn through these on-ramps over here.
Yeah, and if you go on the MathWorks website, in addition to all of these ones that are done within Simulink, so when you launch these are going to be in Simulink on a desktop installation of MATLAB. But there's a bunch of others that you can access from the MathWorks website. If you're brand new to MATLAB, there's a MATLAB on-ramp. There's also on-ramps for machine learning, computer vision. There's a lot of different options online. We're adding a lot of these as we go. A couple of years ago, it would have just been like MATLAB and Simulink.
Yep.
But these are really the best place to get started. They're self-paced. If you already know some of the concepts, which hopefully through watching this live stream, you'll get some introduction, and you might be able to skip the first couple modules of the Simulink on-ramp. But yeah, they're great resources for you guys if you're new to Simulink and you're just getting started. But
cool. Yeah, let's launch a blank model here, and we'll see what you get. So this is what we call the Simulink canvas. So this is kind of your playground, your sandbox to build the models that you want, and this is your starting point, a blank, empty canvas, which might seem overwhelming, but with those examples like I talked about earlier, you can have starting points. But let me just walk you through what you're seeing over here. So like I said, in the middle of the canvas, at the top, you have several tabs on the tool strip. So this tab will be for any simulation-related activities. You have your run button here to run the simulation. I'll talk about that later. You have some tools for debugging the model, for model configuration on this tab. You can even change the format, like if you want to change the background to blue, for example, you could do that if you want. And then this great feature called apps. So applications here, there's a bunch of them. They're kind of GUI interfaces for regular workflows that our customers go through. For example, there's Simulink tests, which is what you can use to test your code. There's an embedded coder, which is what we use to generate C code for deployment. These GUIs make it a much easier workflow to accomplish certain tasks that our customers go through over and over again. So
yeah, if you've ever used the apps tab in MATLAB, there's a ton of apps that are available for different workflows, different things you might want to do, and it's the same thing here. A lot of the times, there's we try to group all of these things you might do for a specific task into one place, and even the core tabs here, if you kind of look at this simulation tab, a lot of what we'll be doing today as we kind of walk through building a model, simulating it, trying to look at data afterwards and understand what happened, it actually flows very well from the left side of the screen to the right. So you get started over on the left. You're going to add blocks using the library browser, which I think you're going to get into in a second here. And as you work your way over to the Run button, and then afterwards, when you're trying to inspect data, kind of take a look at what happened during your simulation, that's over on the right. And most of the tabs are set up that way. It's a useful just sort of organizing thing there, where you can flow from left to right and get an idea of where everything's at. Yeah,
that's a very good point, Sam. I honestly never really noticed that myself, but we're learning something new today. Yeah. So like Sam mentioned, you start on the left, so let's get started here. How do we start creating a model? I'm just going to make something really simple here. I'm going to start with, how do you create a sine wave in your model, for example? And there's a couple of ways to do this. The easiest way, or maybe not the easiest way, one of the ways is to use the library browser.
I think that's where everyone tends to get started.
Yeah, this is a great starting point. It has every single block that we have available in Simulink. We're going to go through some of these commonly used blocks today, maybe. But as you can see, there's tons of blocks, tons of available options. If you're doing aerospace applications, if you're doing motor control applications, there's something for everything, basically. So you could come in here and you could try to find the sine wave block, which should be under sources, I would think. But there's an easier way to find some of these blocks. You can search up here. That'll be an easy first step. So if I want to find a sine wave, I can type in sine, and the sine wave function is here, and the sine wave source, oops, sorry about that. My sine wave source is right here. So I can always just drag and drop this block over, and now I have a sine wave source in my model. So let's try to do this a different way. What if you already know what block you want? You can simply double-click on your canvas and start typing. And sine wave will show up as one of the sources. That's the second option here, and you can just click enter. And there you go. You have a sine wave.
And that's called quick insert. So if you're ever trying to understand the behavior that Simulink is going to do when you do quick insert, the more you use it, if there's a block that you insert with quick insert a lot, it'll actually move it up to the top of your search results. So if you've never used it before, the order is just kind of set in place. But you know, I've been using Simulink for a while. There's a lot of blocks that I use just every time I open up Simulink. And so I can just, even with one letter at this point, I type G, I get a gain, it's already there, and I don't really have to go searching for it. But yeah, if you know what you're looking for, quick insert's a great option. There's a lot of other smart editing features that I'll talk about later, some of the ones that are really useful as you start to build up bigger models. But yeah. Why don't we take a look at this?
Yeah, let's see. How do we see what's going on in the sine wave? So several different options here, once again, to visualize what's going on. We'll start with a really simple one. It's called the scope block. So I'm going to double-click here and insert a scope block. And I'm going to connect the sine wave to the scope block. You can see there's like a little helpful arrow that shows up. You can just click on that to connect the two blocks. And yeah, so I'm going to hit the space bar here. That enlarges the whole model so you can see it clearly. And we can go ahead and hit run right now. See what happens here. So simulation is already run. It's really quick. And if you open up the scope block, you'll get to see the sine wave that we were generating earlier. So really simple simulation here, and you get to visualize the sine wave that way.
So in this case, Nishan, if I wanted to customize what that sine wave is going to look like, maybe I know the frequency of sine wave that I'm working with, that maybe a piece of hardware is going to be sending me, or I measured it on an oscilloscope. How do I change the sine wave there? Because the one you just showed is a pretty big low frequency.
Yep, it is. You know, over 10 seconds, you get about 1.5 waves. So yeah, you can change all the parameters of the sine wave simply by double-clicking on the sine wave, and this will open the block parameters. You know, this little dialog box here will describe exactly what the sine wave is doing. And it also allows you to specify the amplitude, the bias, the samples, the frequency of this sine wave, essentially. And if you ever want to find out more information about, you know, how does this block work, what is it doing, there's a very helpful help button down here. And whenever you click it, it's going to open up Matlab Documentation, which is one of our great resources for understanding how to do modeling in Simulink. You know, I use doc pages all the time whenever I'm stuck, just to understand what's going on, what am I doing wrong here. And this is a great starting point to learn about what you're doing in Simulink. So, you know, it describes what the sine block is doing, you know, in great detail, talks about each of the parameters that I mentioned earlier. And we don't have to go over this now, but just know that this is a great resource that you have at your disposal when you're using Simulink.
Yeah.
So let's make this amplitude 2 over here and spice it up a little bit.
Oh, what did you do?
I don't know. Okay. Invalid sample time.
It's part of working with Simulink sometimes.
Yeah,
so,
and
what if you get the sample time set to?
What do I have the sample time set to? Down here?
No. Go ahead and open the block back up.
Okay. Yep.
Okay.
Ah.
So that should just set it to be a continuous
-1?
sample time. No. That should be fine.
Okay.
I think you changed the sine type to be sample based instead of time based.
Okay.
So
it should be good now.
So yeah, it should be good now.
There we go. Cool. So we have the amplitude set to 2. And we'll run the simulation once again. And if we open up the scope block, we'll see that amplitude's at 2 again.
Yeah.
So we've visualized the sine wave using a scope block, but there's several other ways to do this. One way I'm going to show you is the Simulink data inspector. But first, let's log this signal. So if I select the signal over here, and I right-click on it, and I click log the signal, I can even add a name to it as well, so that's easy to identify. I'm going to call it Sine for now. We'll run the simulation again, and this time I'm going to view this signal in the Simulink data inspector instead. So you'll see it light up over here. Oh, this is not what I want.
Oh, that's your.
That's
a different model.
That's a different model. Let me clear this up over here.
Yeah.
Okay, so this is the sine wave that we just saw earlier, and I can hit this little button here, and they'll expand it. So yeah, another way to visualize the blocks that you're using and the results of your simulations is using the Simulink Data Inspector.
Yeah. With something simple like this, the data inspector and the scope, they're really filling the same role. It's mostly when we move into larger and more complex models, or if we wanted to do a different type of plot, not just time versus the value of the signal. That's sort of where the data inspector comes in, because with this scope block, every signal you want to connect up to it, you have to actually go get that signal wherever it is in the model. You have to plug it into the block. And there's some ways to make that easier. But really, it's just sort of let me just throw a scope on here. I'll take a look at what the value of this signal is. It's really helpful for that. When you log a signal and you get it into the data inspector, it's doing a couple things. So like you said, we can just pull up a normal plot like that. But the other thing is, depending on how you have your model configured, you can actually take all the signals you're logging and export them from Simulink. So say you wanted to do you want to look at some plots here, and you want to compare a couple different signals from different places in a model and kind of look at how they relate to each other. But you have like a post-processing script that you wrote in MATLAB. Because you're logging these signals, you can have them exported directly to the base MATLAB workspace. And so just by flagging something as being logged in the right-click menu, or there's a couple other ways to do it in the UI, you can pull it up on plots really quickly. You can get it into the base workspace for more mathematical analysis if you have some metrics or something you want to calculate on it. And you only have to flag the signal as being logged, and you'll be set for all that.
Yeah, and something that I actually accidentally showed earlier, but is great, is that Simulink Data Inspector actually shows you all the previous runs. So you can actually look back at old runs and compare them to your previous runs. For example, if I set this amplitude back to 1 now and I run the simulation again, in the Simulink Data Inspector, you'll get to see the 1, which is what we just ran. But if I look at the archive over here, I can look back at the previous run that had 2. And I can select that. And now we can see both those runs kind of side by side. And you can always change the color to make it a little easier to tell the difference between them. So I set that to blue. And now you can see 2 runs kind of side by side. So this is really useful if you want to change something in your model, rerun it, and then compare the results to one another.
Yeah. Yeah, Simulink Data Inspector is a really powerful tool. You can actually see that you can configure it to have a bunch of different plots. If you have some similar signals you want on one plot, but you want something else kind of plotted next to it. All of that is configurable. You can also, another cool thing to show is if you bring up the cursor.
Let's do one cursor.
Yeah. So if you're trying to get an actual value for a certain point in time, right? You can pull up this cursor. You can do, with the 2 cursors, you can kind of look at the difference between 2 points, what's going on.
Let's look at that too.
And so here we can see, if we had a bunch of signals plotted, we'd get the values for all of them, and we can start digging into, well, what's my model actually doing? What are these different parts of my model doing? And for a bigger model, maybe we're modeling a vehicle or something, we can start looking at, let's look at engine speed versus vehicle speed, and we can kind of think about what gear the vehicle's in, that kind of stuff. So cursors are really, really good. It's part of what I use Data Inspector for a lot when I'm using Simulink, is just making it easy to throw a bunch of signals in and then look, at the same point in time during my simulation, where's that value at? Cool. All right. Were you going to show the bouncing ball that we used in the promo video?
We did have a promo video, so let me pull up that example. So we had a little bouncing ball example that we showed in the promo video, which I thought was a really cool one. And I thought I'd show you that example today as well. So it's a simple bouncing ball model. I changed gravity a little earlier, but we'll set it back to Earth gravity here. I was just playing around with it. This is what we do with Simulink models. We just play around with different things and see what happens. So yeah, it's a really fun simulation of a bouncing ball. It has a second-order integrator. And you can see in the plot on the scope over here, you'll have the position of the ball over time. and the velocity as well. You have these sharp jumps in velocity from positive to negative whenever it bounces off the floor and changes direction. So that's cool to visualize in the scope. And you can also see the same thing once again in the Simulink data inspector. I'm going to have two different plots here. And so I'll have the position up here. Let me get rid of that sine wave from the last time. We don't want those anymore. So we have the position up here, and then I can put the velocity on the bottom plot over here as well.
So I couldn't help but notice that when you simulated that, Nishan, it actually ran really slow, even though it's a pretty simple model. So can you show me how you did that?
Yeah. So under the Run button, there's an option to do simulation pacing. So I wanted to feel almost like an actual ball bouncing. If I set it to 1 second, so this basically sets the ratio between your simulation time to real world time. So if I set it to 1, then it's going to show like how a ball actually bounces, 1 second at a time. But I can also turn off pacing like this. If I uncheck that button over there and I rerun the simulation, now it's going to go like instantaneously, which is a lot less exciting. But if you're running a lot of these simulations, then this is great. You want it to go as quickly as you can and get the analysis and data that you want out of it. But for funsies, you can always slow it down and watch how the ball progresses over time. So a fun thing I was doing earlier, which was just changing the gravitational acceleration. Like, what if I'm on the moon, Sam, and I wanted to see like how
one of your weekend trips.
One of my weekend trips to the moon. What would this ball look like if it was bouncing on the moon? And that went instantaneously. But you can see that it's a lot more different from how it would be on Earth. I can again compare it to how it looked like on Earth. I'll change the color here, and you can see that on the moon it bounces a lot less.
Yeah. Awesome. Cool. Yeah. So that's I think that's a pretty good introduction to Data Inspector. Something that these models are running a little too fast to really show it, but just like the scope, if you're running a model that's going to take a while, or it's just really computationally intensive, so you can't run it that fast, the Data Inspector will update as the simulation runs. So even as the simulation is running, you can pull up different parameters you might be logging, different signals, right? And kind of take a look at them as the model's running and start to get an idea before your simulation is finished what's going on.
Yep, that's a good point.
The only other thing I'll point out is the simulation pacer, it only slows down a model, right?
Yep.
If your model is, if you were doing like a really high frequency electronics model, of like a motor inverter for a car, an electric car or something, and you have this really fine-grained detail of what the electronics are doing, and you're trying to capture all of that, and it's running slower than the wall clock. So, a really, really high def model, you might see, as you include all of these different effects, it might be a lot slower than real time. Like a second of simulation, you could be taking 10, 20 seconds to run because you're trying to capture so much detail about what your model's doing. So simulation pacer can't really fix that. It can't make it run faster, but for models like this, it's really useful at slowing it down, trying to take a look at what's going on, because if it doesn't really make sense for gravity. We're not going to change the gravity while it's running. But if we had if we were doing a control problem, and I have some models I can pull up for this later, but if you were doing some sort of control problem and partway through the simulation you decided you wanted to change like a gain on a PID controller, you can do that in Simulink. If you open up the block dialog while the model is running, some parameters, not all of them, it kind of depends block to block what's tunable during simulation. But you could change those values while the model is running, and that's a little hard to do when you're letting the model run as fast as it can. But when you use the pacer and you get it set up to slow time down to closer to wall clock time, that gives you more time to kind of interact with different model components.
Yep, cool. Thank you for that, Sam. So yeah, like you said, do you want to jump into some controls experiments and models?
Yeah, I've got a model here actually that I was going to show that kind of walks through some different approaches to modeling. So let me get that pulled up on my end.
Oh, I think we have some questions in the chat, Sam, that we might want to answer here before we jump into this. So first one that I see here is I've completed the Simulink on-ramp where do I go next?
Yeah. So there's a lot of really great resources on Simulink on our website. If you go to like the webinars section, there's a lot of webinars from past, not necessarily live streams. You can always view, come back to this one in a couple weeks, watch this one back. But we have a lot of live streams and videos that we've done on the Matlab YouTube channel. There's a lot of really great webinars, especially for more complex topics in Simulink, like vehicle modeling, airframe modeling in Simulink. You can go there. There's also another self-paced course called Simulink Fundamentals. It's a lot longer than the on-ramp. It covers in a lot more detail the sort of core topics of Simulink. I think it's about 8 hours.
Yeah, it's meant to be over 2 days. The Simulink on-ramp is a 2-hour kind of thing. Simulink Fundamental, it goes like, beyond that and goes into a lot more detail on all the things that you can do in Simulink.
So there is a self-paced version of it. If you go on the MathWorks website, you might find the in-person version of that training, but there is a self-paced one. So I think if you have access to that training through like your university license, I think that's a really great kind of next step on diving into more detail for modeling and controls in Simulink.
Yeah, I also think like a couple of great next steps are to look at other products like that we have. For example, Stateflow and Simscape. Yep. If you're interested in physical modeling, Simscape is, products galore. You have so many options and so many things that you can model in Simscape, from fluid systems to thermal systems. And all these products have on-ramps that you can also do to explore more.
Yeah. All right, so I see one here. Any tips on navigating the Simulink user guide? So normally what I use, and you'll have to forgive me, I started using Simulink about a decade ago at this point, but if you're talking about our documentation pages, I think searching the documentation, if you're trying to do something specific, I don't recommend just like diving into the Simulink documentation and just clicking links until you find something that's useful. It's pretty well organized. There's a lot of pages on kind of breaking down specific subsets of what you might want to do in Simulink, right? There's different pages for like model management, different simulation options. I think it's the best way to go about using it is think about what it is you're trying to do and search specifically for that. There's a lot of documentation. We try to document everything we can. We have a whole team for every toolbox. There is a dedicated documentation team, right? So the documentation is there to serve as a reference. And if you've got questions about specific blocks and stuff, it's got a lot of information about those. So especially if you're trying to get started with like a new toolbox or something, I would pull up that toolbox's documentation page. And usually where I get started, honestly, is the examples page. If I just pull up, let's see, if I just go to the Stateflow product page, well, really what I want is the documentation page, my bad. So I go to the documentation page. I pretty much always start when I'm just getting started with a product or something. I go to the examples. I kind of pull up one or two that I think are going to be useful. So they're generally broken down. So even though there's what is this, a total of 77 examples listed here, I'd get started with let me look at chart programming basics. Kind of look at different syntax for states and transitions. I'll pull one of those up. Another really great thing that I usually do, especially when I'm new to something, is I'll open up this videos section. So this is basically, of all the videos on our website, it's breaking it down to just the ones relevant to the section of the documentation I'm working on, right? So I think those, the examples and the videos, that's where I go to if I'm new to something or I just haven't done something in a while in Simulink, and I'm trying to remember how do I kind of build up from basics there. Those are the two sections I usually go to. And another thing you could do is you could go to MATLAB Answers. So when you search something in the documentation, like if I had a specific question on how to do something, it'll include results from MATLAB answers.
Yep.
And so that's kind of a place where you can ask a question. A lot of our developers, other people here at the MathWorks, were on those pages, as well as some just really great members of the community that answer a ton of questions, way more than I think I could ever answer.
Honestly.
Image analyst, Walter.
Yep.
Those folks, you know, they're answering questions quicker than I think we ever could. So there's that community is also there and available. So if you have a question on where to get started or how to model something in Simulink, Answers is another really, really good place to
I do want to add on quickly to what you said about examples, Sam.
Yeah.
The examples are not going to throw you into the deep end. It's not going to just be a Simulink model and like, all right, go figure it out yourself. You know,
Yeah.
All these examples are accompanied by live scripts with descriptions on exactly what is going on and what this model is accomplishing. And so reading through all that gives you a very good sense of, you know, what is this example all about? It's not just, see, like this example over here, for example, describes the model, describes the chart or the state flow object, and kind of walks you through what this model is accomplishing.
Yeah. But state flow, that's a topic for another day.
Yep.
It's a really great tool, but just a good example of how the documentation pages and the examples really kind of break down something complicated like this and walk you through getting started with it. All right. So I wanted to talk about everyone's favorite system. If you've taken a system dynamics class, as a mechanical engineer, I don't know what the classic example for electrical is probably something like
The LC circuit, RC circuit,
yeah.
one of those.
RLC.
RLC circuit.
But I think the quintessential example of a system that you might want to build a model of, even just for demonstration purposes, is the mass spring damper. You can simplify a lot of systems down to kind of like they are a mass spring damper.
Yeah.
If you think about a car, right? You ride along the road. It's a little complicated because you've got 4 wheels, 4 springs, 4 dampers. But if you really like, you can simplify it down and really think about what you've got. It's a big old mass. You've got your vehicle, and it's got a spring and damper that's responding to input from the road. There's some force that the road is exerting on your wheels and tires. Yep. And how that comes back to your mass in terms of its movement. You can represent that as probably the more in-depth way to do it from even just a simple free body diagram like this. You might have a couple different springs, a couple different dampers, that kind of stuff. It depends how much detail you want to get into, and if you want to include things like the fact that the front of the car is going to move independent of the rear and stuff. But
we can get real complicated with it, is what you're saying.
Yeah, yeah. And I've actually got a model I can show in a bit that kind of goes down. Okay, like you take a simple thing like this and you want to piece together different components, but spoilers. We don't want to give it away.
So walk me through what you're doing here, Sam.
All right.
We have a mass spring damper.
We got a mass spring damper.
Okay.
What I wanted to show basically is that there's kind of 2 ways that back when I took system dynamics, the way that it'll probably be taught if you're taking a system dynamics class, there's really 2 ways that you're probably going to model this, right? And those are either going to be a state space representation or a transfer function. There's different schools of thought of which one to use when, and I'm not trying to start an academic debate about that. But this system can be represented as both, and so. I've actually got, if you did some work by hand, you're looking at your system, you're kind of examining what states you've got, what different parameters you have that you want to include, and you've already done all that work by hand, you can bring that into Simulink using these state space and the transfer function blocks.
What is this state space block, Sam? How do you even get to it?
Okay, so I used quick insert.
Okay.
But if you look in the library browser, let me open that up really quick. And I looked for state space.
Just gonna look through our thousands of blocks here.
I got a lot of toolboxes installed, so it takes a second. But and I only just installed 22B, so it hasn't looked around. So you can see one of the things that pops up with is actually a discrete state space. There's a bunch of other stuff from. Didn't mean to open that. From my different toolboxes where there might be different things I want to include in my state space model. There's a lot here from the aerospace block set on specific things to aerospace modeling, but I'm just using a generic state space. Tripping over my own words here. I'm just using a generic state space block here because mass spring damper is pretty simple. I worked it out by hand, and this is what I've got. So my A term here, and it kind of breaks it down here, right? In this case, my states are my position and my velocity. So the dx dt of those is my velocity and my acceleration for my mass. So I've got my A matrix here, using K as my spring, C is my damper, damping rate, and then M is the mass. So I've got all of these in terms of those parameters in case I want to change them, see how they behave. And then I've got the same system represented as a transfer function. And so I've got my M, my C, and my K. And I'll show that these are equivalent in a second, because the third way that I've modeled this, and this is sort of as we get into bigger models, things that it's just not, it's either not feasible or it doesn't make a ton of sense to try and work it all out by hand first and then bring it into Simulink. I don't have to do that. So here I've got the exact same model of the same system, and I'm just doing it using core Simulink blocks. So really, if I look at this add block, what this is I'm taking my input force and I'm subtracting the forces that are acting on my mass from my spring and my damper.
I see that.
So I've got those coming back, and so you may look at this and you look at it and you say, well, that's a loop. I've got a dependency. In this case, my integrator here has an initial condition of 0, and so I actually know for the first time step, Simulink is going to be able to work out what the damping force is, what the spring force is.
That makes sense.
But this is something that can happen when you're working with Simulink and you're looping back values like this. Is you can get what's called an algebraic loop, where Simulink isn't able to solve this system of equations for you, and you may need to, there's some good documentation pages on how to solve algebraic loops. It's especially as you like throw different models you've made of different components together, and you're just not thinking it's 11 o'clock, you've got an exam the next morning. It's something that can happen. There's good documentation on how to make sure that you can resolve those. But here, what I'm doing is I'm solving for like the net force. If you were to draw, free body diagram, kind of add it up, and I'm dividing by the mass of my mass spring damper to get the acceleration, and then I'm integrating the acceleration to get my velocity and my position. Now I could have solved for the velocity if I really wanted to. I could have solved for velocity. And then taken a derivative to get acceleration. Same thing, I could have solved for position if I really wanted to, and I could have then derived it twice to get acceleration. But in general, when you're doing this sort of equation-based modeling in Simulink, you want to get the highest order first and integrate from there. There's a lot of things that can happen when you're trying to take derivatives, especially multiple derivatives of my acceleration. If I then take another, if I solve for position and I took a derivative to get velocity, that's probably fine. And I take another derivative to get to acceleration. The numeric solvers in Simulink, it's a lot easier for weird things to happen that I don't want to have to be fighting the software, right? So it's generally a good idea to start with the highest order and go down. Now, I could do something, if you guys know what jerk is, not me, the physical property jerk. So it's the derivative of acceleration. So I could take a derivative here, and because I'm just doing one, I wouldn't be that worried about it. But if I was like solving for position and then trying to do 3 derivatives to get to my jerk, that starts to worry me a bit, just from a modeling standpoint, where I'm like, ooh, something could happen here in my model where because I'm doing all these derivatives, it just spikes really hard, and that might not be representative of what the system would actually do.
Yeah, real quick, Sam, you're using these alphabets here in this model. You have M, C, and K.
Yep.
Those are not numbers. How does that work in Simulink?
Yeah, so in Simulink, when I'm setting up these block parameters, right, so I've got this gain, and you can see I've entered 1 over M because I'm trying to divide that force by my mass. I have those parameters defined in my, let me zoom in on this here, in my Matlab workspace here. So I set these up beforehand just to have something to go off of. But the main reason I did it is now so I've got these 3 different models. If I want to change the mass, and I want to make sure it updates in all 3 locations, I don't have to go to 3 different blocks, change the parameter. They might be buried somewhere in a subsystem or something. I don't have to go find them. I can say, okay, well, I'm going to change this mass value, and it's going to update in all 3 of my representations of this mass spring damper, and I don't really have to worry about it.
That makes sense. This is another example of Simulink being built on top of MATLAB. We're changing variables in the base workspace here, which is what Sam was just showing. But Simulink knows that because it's built on top of MATLAB and can pull those numbers and those values from the base workspace.
Yeah, and because I'm not changing them, right? What's going to happen is it's going to, when I hit run here, it's going to look in the base workspace for what M is.
Yeah.
It's not something that I can't change it in the base workspace and then get updated values in the model, right? So that's something to keep in mind if you're trying to loop through a couple different values, right?
Yeah.
It's not something that changes dynamically. Because it's just getting checked right when I initialize my model.
And one thing to note is that if you keep that block open for a second, Sam, if you look to the right of that 1 over M on the right side, you'll see actually the value that Simulink is computing. So it's already pulling that M value. It's already saying like, oh, okay, you specified M as 1, and I know that, and I'm going to show you that number here as well. So. Yeah,
and if I wanted details on where M is coming from, I can click these 3 dots, and it actually tells me, hey, M's in the base workspace. If you want to kind of explore the different parameters I've got available to me, it's here.
Yep. Cool.
All right. So just to prove that I'm not,
it's a lot of suspense.
I'm not lying, and that these models are actually the same. You can see I've got 3 different models here plugged into my scope in my one Simulink file. Let me change the layout of my scope. So I've got all 3 here. But as you can see, if I enable the legend.
Yeah, prove it to me, Sam. Okay.
So
okay, now I believe you.
You can see I've got my state space, my transfer function, and my equation-based one, but you can't see them because they're all producing the same values.
You can double-click on each of those lines. You have to hide them.
Oh, I probably should have started with the one on top of the others.
Yeah, okay, that proves it. They're all there.
But so I just had it set out with the 3 just so we could see all of them independently. But you can kind of notice with the parameters I've got right now, I'm not really seeing the entirety of the behavior, right? So what I'm going to do is I've got, over here in the simulation tab, I've got my stop time. So I'm actually going to set that to 60 seconds.
Okay.
So I'm going to simulate 60 seconds of all 3 of these mass spring
How long is that going to take, Sam?
Oh, maybe a second.
Okay, there it's done.
Maybe even less. So now I've got a lot more of this behavior, but I've got something else going on now. And this model is pretty simple, and so it's not causing issues for me. I'm still getting basically the right behavior.
Looks a little jaggedy.
It looks pretty jagged.
Yeah.
I don't think, for the, what is that, like half a second, I don't think my mass spring damper was standing still.
Still for a second,
right?
Yeah, it seems unlikely.
So what this is when the Simulink Solver is actually, because I've got all these blocks, right? And what's happening is Simulink is trying to solve the system of equations that represents all of these blocks.
Okay.
The way I have it set up now, I'm letting Simulink actually decide what step size it should take.
Okay, so like how often it should make those calculations, essentially.
And because I don't have any nonlinearities, I don't have any thing that like triggers at a specific time.
Yeah.
There's not really much that can go wrong. But this is because I know exactly what this should look like. It's a mass spring damper. it's really highlighting why having my sample time be completely dependent of like Simulink, you figure it out.
Yeah.
You'll figure it out. I've got some issues coming up. I want that data in between. So if I actually go to my modeling tab, I've got the model settings or the model configuration parameters. If you're old like me and you were around before the Simulink tool strip.
Yep.
And I've got this tab for Solver. So this is the Simulink Solver. The other thing you can see actually is down in the corner here is the solver is set to auto. So I'm letting Simulink pick which solver it's doing, and it chose ODE 45.
Okay.
And the documentation, if you've used like the ODE function in MATLAB, it's a lot of the same solvers.
Okay.
The documentation kind of covers what each one of those is. So I don't want to get too into detail, but that's like the standard variable step. Most of the time, if you build a model and you leave it on auto, it's probably going to pick ODE 45. But I want to tweak some settings, right?
Okay.
I don't actually want to let Simulink do everything for
Yeah.
me. So in this
See what we
case,
got.
I want Simulink to still have control over if there's really high frequency stuff going on in my system. I might still want to have a variable step solver. But rather than letting Simulink figure out what the maximum step size and the minimum step size and stuff like that is, I want to basically tell it, hey, I'm not going to let you take a step size smaller than maybe, I'm going to do 0.01.
Okay.
Probably excessive for this model, but and so now instead of these little jagged lines, they look nice and smooth.
Wow. Okay.
Right? And it really it's going to depend on your system, right?
Yeah.
And what you're modeling, how detailed you're modeling it, what an appropriate step size is. If you've got high frequency components or something in there, if I changed, if I added some nonlinearities to my model, the solver will try to handle those. It'll actually shrink down for really intense things where a lot is happening in your model. It will actually shrink down the step size during those transitions. And then when it's kind of steady state, it'll go back to taking really big step sizes. So variable steps are really, really useful for plant modeling, continuous systems, where you've got a representation of something physical that's happening. The other thing you may be asking is, well, if there's variable step, what is this fixed step?
Yeah, what is fixed step?
The short answer is all of that stuff I just talked about where Simulink's getting to pick what my step size is, right? Is I'm telling it, no.
So you're taking control here.
I'm taking control.
Okay.
I can still let it pick what the step size is.
Yeah.
But I'm telling it, I need you to calculate it at 1,000 hertz, right? And so I apply that, and then I run it. And so now you can see down here, it's actually saying it's still auto, but it's a fixed step size.
Gotcha.
And unfortunately, that was actually maybe too big of a step size. So it looks exactly the same.
Yeah, it does look exactly the same. So I couldn't tell you the difference.
Yeah. But the reason that's important, actually, and we'll talk about this in the CodeGen live stream next week, when you're talking about like embedded controls, you're generating C code from a Simulink model to deploy onto like a microcontroller or something.
Yeah, this is what we taled about at the very start of the call with model-based design. We've done the simulation. This is the deployment phase. We want to put it into a controller.
So in this case, I'm just working with like a really simple model of a mass spring damper. But maybe I've got a PID controller that I'm going to put on an Arduino or some other embedded device. Those embedded devices, they have to run at a fixed sample time.
Okay.
And so when we're mixing these continuous systems, like our physical plants and our control systems that run at a fixed rate. When we go to generate code, we have to have everything running at a fixed rate.
Step,
but we can mix and match. I could, that same Sine block that you were using before.
It's the second
that's not the block I want.
It's a sine wave.
Yes. So you can see I've got a sample time of 0. So that's actually telling it this is a continuous signal.
Yeah.
If I were to put like 0.1, you can actually see
it there.
It changes to this this stepped image to show like, hey, this is a fixed sample time. It's only going to output at 10 hertz.
Yep.
And so that's something to keep in mind especially if you're looking at like, I need to measure data from a system. Fixed sample times can really come into it in how often you're actually checking what those values are. All right. I did see that we had a question in a chat. I'm studying battery management systems and mostly focusing on active BMS. Should I learn Simscape or Simulink? Is Simulink enough? So you might have an opinion on this.
Yeah, go ahead.
And my favorite answer, it depends, right? Yep. What I'll say is that when it comes to physical modeling, Simscape is a really, really good tool. And if I open up, let me open up the Simulink start page just to show it. Simscape is another modeling language that's included in Simulink that's specific for physical systems. So like what I did right then is I'm looking at, well, I got to write up all the equations for all my systems. Simscape is sort of dedicated to physical modeling where maybe I know the equations that represent an individual component, and I'm going to piece a bunch of these components together, and they have directionality. Like what happens in my electrical circuit impacts what's happening in my battery. And rather than trying to do all these loop backs and all this stuff, Simscape is a really good tool for modeling that kind of physical system. Yep. So I will say, I think with core Simscape, as well as there's a new product in 22B, a new toolbox called Simscape Battery, which is really intended for like if you're trying to build a cell level model of a battery system. There's a lot of tools in Simscape Battery to help you with that, right? You could totally do it entirely in Simulink, because I can build, whether I have a state space or a transfer function representation, or I want to kind of build it up myself as an equation-based thing. You can do that in Simulink and then have your control system, your battery management system, kind of tapping into that to do whatever management software you're trying to develop. Yep. I will say I think it'll be easier to do in Simscape, and I think because Simscape is such a great tool for modeling physical systems like that, if you, for example, want to include a thermal model, Simscape has, it's got electrical models, thermal models, a mechanical model like a mass spring damper, you can include that kind of stuff. So to me, I think Simscape would be the stronger option, especially if you're still in school, right? It's a really great tool to learn for modeling physical systems.
Yeah, I completely agree, Sam. I think like a battery management system, you're going to be looking at a lot more than just the electrical components of it. Like you just mentioned the thermal systems, and modeling all that in Simulink is possible, but Simscape gives you just such great tools. And we've actually had some live streams in the past that compare modeling a mass spring damper system in just Simulink versus using Simscape. And you can, even visually, just seeing it in Simscape sometimes can be a lot better than modeling it in Simulink. So Simscape's a really powerful tool, and
Speaking of looking better, this is a model, a demo model that's one of the examples in the Simscape doc. And it's not super complicated. It's actually a double mass spring damper, so one sitting on top of the other. And you can see the left is how you would write that up as an equation-based Simulink model, because the movement of one mass impacts the other one. On the right is the Simscape representation, where I've got physical components, right? I have a spring, a damper, a mass, and I connect them up how they're connected in my system. And to add on top of that, I just put another mass spring damper on top, right? So it can really simplify working with a model, right?
Yeah. Cool, we have another question here. Does MATLAB have an online Simulink service? The answer is yes. MATLAB Online was launched a few years ago, and it's a great tool when you don't want to download the entire MATLAB product onto your computer. You can always use MATLAB Online, and likewise, there's an analogous Simulink Online as well. So if you go on MATLAB Online, you can launch Simulink just like you did when I showed it at the start of this live stream. You can either click on the Simulink icon on MATLAB Online, or you can just type Simulink in the MATLAB Online command window, and it will launch Simulink for you as well. So A great feature to have, reducing the footprint on the computer by having it online.
And a little preview of things to come in desktop MATLAB, because MATLAB Online, because it has to be able to display in a web browser, is using a different front end right now than desktop MATLAB. But you can see MATLAB dark mode in the browser. So this is coming to desktop MATLAB. This is just because the actual UI is rendered differently in a web browser, that we can do it in MATLAB Online right now. But I've got a bunch of functions here in my own my MATLAB drive of just different stuff that I've kind of tested out. I've got a computer at home that only has 4 gigabytes of RAM. And I don't really want to I don't want to install MATLAB on it because it doesn't have a ton of disk space. So when I'm trying to just mess around with MATLAB, maybe try some scripting out on that machine, I just use MATLAB Online. In this case, you can probably tell from the camera, my laptop's pretty bulky. It's pretty performant. So I can just run MATLAB on here. I've got a bunch of different versions of MATLAB installed, so I can mess around in different ones. But yeah, definitely on the BMS question, I definitely think Simscape is a good option. And maybe we'll do another live stream on that in the future.
Yeah.
But next one we're doing is code gen.
Code generation. There's one other thing that we wanted to talk about today, which is the student competition or the student challenge.
Yes. So I've got a slide here that I wanted to throw up.
Cool. Let's talk about that, Sam. What is the student challenge? How do I earn some money here?
So the Simulink Student Challenge, we do this pretty much every year, but it's an opportunity for students to really show off what they've learned in Simulink and show something cool and get recognized for it. If you go to the Simulink Student Challenge website, which I think we'll put a link in the chat for, you'll see the past winners, right, and the projects that they've done. And it's just a really awesome opportunity to kind of show off work that you've done in Simulink. So hopefully we've inspired you to get started with Simulink, do something cool with it, make an entry into the Student Challenge. The really important date, and you'll see it right here on this slide. And if you scan that QR code with your phone, the site should have these dates as well. But you need to submit an entry form by December 12th, 2022. So coming up
about 2 months.
2 months.
Yeah.
And it's by 1 p.m. Eastern time. So if you really feeling inspired, you want to go try out some stuff in Simulink, make a cool video about what you've done, go sign up for the Simulink Student Challenge. It's really awesome to see some of this stuff that students are doing with it. So
yeah, and one last plug for next week. Is it next week, Sam?
Yep, next Thursday.
Next Thursday, Sam and Connell will be doing a code generation live stream. So going through the second steps of what we're talking about today. We did some modeling today, but how do we make that into code and deploy that onto some hardware? Sam's going to go over that next week. But
yeah.
It's been a pleasure having you all join us today on the Simulink live stream. We hope you guys got a bit of an insight into how Simulink works and learned a few basics.
Yeah, so go check out the Simulink on-ramp and come back next week for another live stream.